We have done a few layout. Now we look at another category of layout we call service layout. So I put a side note here. The one that we're going to look at in this session will be service layout. It will be different from the manufacturing layout or assembly layout. So most of the service organization, they use a process layout, right? So what is the service layout look like? Okay, the service layout will be a bit different from the process layout, right? Just now we talked about process layout, and most of the organization, they use process layout, but now we're going to look at service layout. So what is the differences between service layout and process layout is their objective. So this is the process layout where you go and access your item necessary. However, in the service layout, you can see that the change of the setup here. When it comes to service layout, your customers was exposed to all your inventory, while the process layout, you are more focused on the process. However, when it comes to process layout, you are more on the customer experience, right? You can imagine on the left-hand side is a normal factory floor. What is service layout example? You have been to IKEA, right? Or IKEA, the furniture franchise shop outlets, right? So you are designed to move in a certain way, only one in and one way, and then you will see all the arrow on the floor, guide you through all the section, and then you come back to the cashier. This one. So for the process layout, all right, you minimize the flow of the paperwork, or you maximize the customer exposure. Okay, so for service layout, in short, you think of IKEA or IKEA, where you focus more on the customer experience, exposure to your products, rather than very passive way. You wait for the machine to come and pick up the products, right? Okay. Yeah, as IKEA is one that you are familiar with. Another traditional business, they also use service layout, where the convenience store or your grocery store in your town, where sometimes the boss, they purposely put those hot sale product at the last corridor of the shop. If you go to Mr. DIY, normally they will put the most favorite or most high hot sale product at the back of the store. Example, grocery store, they put milk or bread at the last corner of the shop, so that you are somehow forced to walk into the store and exposed to all the things before you reach to the milk corner or to the bread corner. Okay, same thing done by IKEA or IKEA, right? So you purposely design in such a way where you have to walk, pass through a different section, and then you get your things that you want to buy, right? Then you check out. Okay, this kind of service layout, one of the benefit is at the end, the customer will purchase more than the original plan. Is to push additional sales. Okay. So again, service layout one of the objective of or one of the motivation why the owner choose service layout is to prompt for additional sales, right? Okay, so keep in mind, imagine how you experience in IKEA or IKEA department, right? So you have a lot of different type of store layout that you can choose under service layout. So we have four, the traditional four layout. First, free flow. Second, grid layout. Third, spine layout, and loop layout. Okay, look carefully on the diagram. So under service layout, you have four types of store layout that you can use. Either you use a free flow, you do the grid layout, or spine layout, or loop layout. Now, by the diagram and the name itself, I think you can relate to what kind of business or what kind of shop that you have been to, right? Free flow layout, normally you will find in the big sales or store, convenience store, or super mall that big shopping mall that have big sales, where the customer are free to move around and pick whatever they want in that particular space. All right. I'm not sure whether you've been to a sales clearance in the factory setup. A factory floor, they put a big banner. They say big sales, year-end big sales or clear stocks sales. So they will open up the whole production floor and they put all the products in the space there, and you're allowed to walk all the way you want, in the freeway. Grid layout, this one, normally grid layout and a spine layout, normally you'll find in the buffet, buffet layout, or grid layout you will also see in the IKEA, IKEA layout. But you can relate to space that you've been to. So grid means the customer will go like this one. You control the flow. This one maybe you will see in the Giant, right? The Giant. If you go and buy the daily goods, the snack section, the soft drinks, or your instant noodles, wine or beer, okay. So you have this layout, okay, where you can push your trolley, go this way, right? Okay, spine layout. Spine layout in Malaysia. Can anyone give example of spine layout? When you go shopping, you see something like this, where you need to go in and then come out again, go in, come out again. This kind of some buffet or restaurant, they use this setup. Some buffet, they use this one. What else? Yeah. So anyway, you by the diagram, I think you can relate. Look, this one normally in the museum or in the aquarium. Aquarium, you go to aquarium, you go to museum, you go to arts exhibition or arts auction. They will put in a loop. They'll put you in a loop to walk around and see again. Okay, so something like that. This one, you try to relate but the shape is like the spine, a fishbone layout. Okay, now let's look at the first one, free flow. What are the advantages? What are the characteristics? So when you are using free flow, they're actually encouraging browsing. Means once you walk into the store, you can see all the section. You can see all the section, all the products in one view, so that you know that you can. Okay, some of it you can see this one in the in the we call book festival, or some of the festival, right? You walk into the car park and then you see, wow, there's lots of things there, right? It increased impulse purchasing. What I mean by impulse purchasing means you want to grab the thing and then you go, right? You want to attract the customer to buy things very fast, go in and go out very fast. And it's very flexible. Normally, if you use a free flow layout, the staff that you employ, you don't need to have somebody stand there to demo, to show the customer what they want. Okay, so if you choose a free flow, in some of the convenience store, one department, for example, men garment or kids toy section, sometimes they use a free flow layout. Visually appearing, meaning there are lots of things to visual. Once you walk into the layout, into the space that use free flow, usually there are lots of colors, there are lots of banner, there are lots of lighting, there are lots of signal. Ask you to buy this one sales, that one sales, that one. Okay, visually they are appealing. This is the characteristic of free flow layout. Second, we look at grid layout. So grid layout is for those old customer, meaning they will train the customer mindset that every time I walk in, if I want to go to buy soft drink, I go to particular rack to find. Means they fix already. Okay, this rack is for what? Is for certain item. So they don't change the area for that particular products, so that the customer, every time the customer want to buy something, the customer can straight away go to that section and buy. Okay, so this one is to train the customer to familiarize, and then even though sometimes they'll put the number there, okay, the customer say, oh, I want to buy something, then the cashier or the customer service officer, they will tell you, okay, go to lane A, B, lane B, second row to pick up the item, right? They are very low cost because you don't need to have a lot of movement. You just put it there, display. Easy to clean and secure because you can put this all this rectangular layout here, the cabinet here. You can lock them. You can clean also. You have a standard procedure just to clean. Very easy to clean, right? Usually, this kind of setup is for standard products, and you are cater for repeat customer, or you are cater for old customer, right? This is for the grid layout. The next one will be spine and loop layout. These two I combine together because they are between the free flow and the grid. Okay, they are between the free flow and grid. Both are good in customer line side, side light. That means the customer can view everything. While it encourages the customer to walk around the store. Okay, so these are the characteristic of the spine layout and the loop layout. Again, these two fall between the free flow and the grid just now. It just fall between that one. Again, there's no best layout for operation. You just need to choose whatever that is suitable for that particular marketing style, right? Okay, so these are the things that you need to concern. So I'm not going to go all these things. So you can read from here, right? So service layout, there are some concern that you need to prepare for. Okay, first, the space that you need, or available space in your department or in your store or in your business? Second, is there any special display that you need to show to your customer, right? For example, the shop that sell gold jewelries, they have a different setup compared to those selling accessories, right? So a bit different. And also, how do you improve the payment procedure, or the checkout procedure? Once the customer go in, how do you improve the payment or checkout procedure? And the last one is most important one, is protection from thief. From thief. This is a very, not sure whether I can. This word, pilferage, is very high standard word. Sound like very standard word, but it just means thief or shoplifter. I give you one video that I find in the YouTube that I find quite interesting. Right? Okay, this. Okay, so from the video just now, and you can see the layout of the shop, right? So the type of the layout also you need to consider, right? Because humans are very complex living creature. So we have a brain. So sometimes the talent used in the wrong way, then you're going to hurt someone. So again, when you design the service layout, one of the thing if you go to work later on, is main concern is the security, right? So how you safeguard your products, and also how to use secure the safety of your staff, right? So for example, if you open up a gold shop, right, a gold jewelry shop, so the procedure of checkout will be different. The type of the display will be different. Yeah. So these are the examples that I can give you under service layout. So these are the two terms when you talk about service layout. One is the back office, one is the front office. So what I mean by back office? Meaning the office is behind the door, right? It's within the shop, but it's behind the door where your customer cannot see actually there's an office. For example, if you go into those wearing glass, wearing spec, if you go to a spectacle shop, normally you don't see the office, right? Something like that. So that called back office. You don't see office when you walk in, you don't see the staff office. The next one is the front office, where you have a customer service. Front office, most obvious one is the hotel industry. Right? When you walk in, the first thing you see is the service officer, the check-in counter. Right? So it depends from operation to operation, but these are the wording used when they design the service layout. Either you're having a back office setup or the front office setup. So if you those that having back office setup, they going for efficiency and functional, meaning they have an operation running behind the shop. For front office, normally they go for services. They will focus more on services, and they are visually pleasing. All right, the customer will feel good every time you put a front office. If you design a service layout with a front office, normally you will go for service, customer service kind of business. All right. For example, front office, this one, those going for cosmetic service shop, then you have a front office. For example, those go for nails, girls, you go for nails polishing, all these. So straight away you go into the shop, the staff already ready to serve you already, right? This is a short highlights. Product layout objective is to balance the assembly line. Now we go into product layout. Just now we talk about service layout. Now we talk about product layout, and also they also have a very good exercise later on, if we manage to cover today. So what mean by product layout? Product layout, it means assembly line, where you're focusing on machine and the workers. Right? Product layout, it focus on machine and layout. Service layout, just now you think of IKEA, it focus on selling the products or products. Okay, product layout, more focus on the machine, how you arrange the machine and worker. Yeah. The rest you can read. Yeah. These are the terms that you will see. For example, work element. Okay, this one you can read. And for product layout, again, the objective is to make sure there's no problem in the assembly line. Is to make sure the flow always very smooth. The process that makes a smooth assembly line called line balancing. Later, there will be one tutorial question on line balancing. Right? So under product layout, you need to do line balancing. Why line balancing? It is because your objective of product layout is to balance the assembly line, meaning that you equalize the amount of workload at that workstation. Meaning you equalize mean you reduce a pile build up of the workload, right? Yeah. Okay. Let's look at line balancing, right? Line balancing. Okay. So when talk about assembly line, there are two main factors to consider. One is the requirement of the precedence. So what I mean by line of requirement of precedence means if a product you need to make, let's say the product need process A and B, and before you come to the process B, you need to do process A first. So this is the requirement. Precedence requirement means a process that you must go through before the next one. All right. I'll give you an example. Normally, when you go into the gift shop, what is the last process? Is wrapping up the gift, right? So when you go into the gift shop, you have to buy the gift first, right? So you won't write up the gift first, then you buy, right? So there is a precedence requirement. So you need to buy the things, you need to do the thing first, then only you can write up the things, right? For example, the McDonald's, the burger operation, you need to cook the fries, you need to shear the burgers, meat, and so on. before you write the burgers and put things together, right? So these are the things that you need to consider for the precedence requirement. And next one is the time. There are two things. One is the precedence requirement, what you need to do first, what are the process that important to go through first. Another one is the cycle time or the time element. So these two, when you do line balancing later on, when you look at the tutorial question later on, consider these two things. What are the things that you need to do first? Second one is the time. What are the time restriction for each process? Okay. These are the two definitions you can read through. Okay. Precedent requirement and cycle time. Cycle time focus on each workstation and focus on the maximum amount needed for each workstation. Workstation you can imagine as one process. For example, drilling hole, that station purposely for drill hole, then that one consider one workstation, and the time to drill maybe 6 holes, maybe is 2 minutes. So that is the cycle time for that process. I'll give you an example. This one is the one that I illustrate to you just now. The burger cases, the burger process, you don't write the burger first, right? You cook first, then you write, then you send to the customer. Later on, you will see a diagram called precedence diagram. So we will put all the requirement in the diagram. This one is a little bit different from the example one that we did previously. This one, previous one, you will see the load diagram. Now, today you will see precedence diagram. Precedence diagram means all the requirement, what process need to come first before the next one. You cannot jump queue, so you need to follow the regulation, the requirement. This is a definition for precedence diagram. You can read. Actually, it's just a diagram that show the relationship in the process from point to point. So you can read through the slides. There's one equation we call desired cycle time, given by this one. I think this one is the first equation for today. CD, cycle time for desired cycle time, C sub D. We take production time available divided by desired unit of your output. Time above divided by unit. Okay, how many times production times available divided by desired unit of output. I'll give you an example. First example for our first equation for today. C sub D is desired cycle time. You take time divided by your unit output or output. So let's say you have this statement. A company produce 120 units in 8 hours a day. So this whole day he create 120 units. The cycle time can be calculated as follow. In this calculation, remember the unit that we use will be in the unit of unit and also hours. You need to change your time to minute. Okay, to use this equation, the standard unit in your calculation, always change the hour into minute divided by the total unit of your output. Okay, something like this. You need 8 hours to produce. You need 8 hours to produce 120 units. Convert the time that you use to produce 180 units. 8 hours, 1 hour 60 minutes. All right, 8 times 60. You convert this one into minute already. Divided by 120 unit, you get the desired cycle time. Again, the word is desired cycle time. It's not the actual cycle time. You have two types of cycle time, desired and actual. The word desired means something that your manager want to do. The keyword is wanted or desired. Okay. So in the question, in the test one or as a final exam, read carefully the statement we give to you. If you see wanted, it means you go and calculate desired time. The products that or the equation that you use to calculate something wanted is fall under desired cycle time. And you read the statement later, you say the machine in the production floor produce something. That one under actual cycle time. Okay, so have some personal notes in on your side there. Desired cycle time is what you design to do, not the actual one, just a design to do. What is a perfect case, right? So again, the keyword is wanted or planned, P-L-A-N-N-E-D, planned, or estimate, also can be estimate, right? So you do calculation, you get 4 minutes. Okay. Any question on this equation, on desired cycle time? Okay, everyone okay? Everyone good, huh?
Yes, okay, Doctor.
Right. Next, we talk about cycle time. Cycle time and flow time. Now, just now I introduced you the cycle time. Now, what is flow time? So I give you one example here. Cycle time is the time from the first station to the last station. So let's say workstation number 1 required 4 minutes, station 2 require 4 minutes, station 3 require 4 minutes. Your flow time is 12 minutes. You add the station 1 times, station 2 times, station 3 times together, you get 12 minutes. However, cycle time is the maximum time in the production flow. In this case, 4 minutes, 4 minutes, 4 minutes, maximum 4. If, let's say, I give you, okay, this example you understand, right? I change a little bit this diagram. Let's say you have 449, 4 minutes, 4 minutes, 4 minutes, 4 minutes, 9 minutes. Your cycle time is 449. Choose the maximum. Maximum is not 4 minutes, but 9 minutes. Okay, you choose the upper limit of the time. Okay, in this example, maybe you didn't see the differences, but I need to highlight that one because the number used in the example is the same. But what happened if I change one of the station? All right, so let's say I change the last one, 441, 4 minutes, 4 minutes, 1 minute. Cycle time 441, you still get 4 minutes. Choose the maximum number in the production flow. Okay, this is the difference between cycle time and flow time. So don't be surprised if this kind of simple question come up in the test 1 or final exam. Don't confuse between flow time and cycle time. The question will be specific, mention, calculate flow time of the layout. Calculate cycle time of the layout. Or the question might be tricky a little bit. It asks you, find the differences between flow time and cycle time. Meaning, differences means you take this one, minus this one, you get the differences, right? Okay. We have clear what is flow time, what is cycle time. Yeah, anyone? Go ahead. Anything you want to comment? Any questions?
Yeah, Doctor, if 449 means then the maximum is 9.
Yeah, means cycle time is 9.
So if you ask difference means is 9 minus
Yeah, it depends
flow,
on the, yeah. I
you
asked
have
you
to add.
about Yeah, I asked you about the differences between flow time and cycle time. You take this one minus this one. Means the difference between the two. Important is the concept of cycle time. You always pick the highest time spent in the workstation. Even I reduce this one to 1, 4, 4, 1, 4 minute, 4 minute. Last station, even you spend 1 minute here, the cycle time still 4 minutes. Means the maximum time I need to wait in my planning is 4 minutes. Okay, even I change the first station to 1, 1 minute, 4 minute, 1 minute, you still get 1, 4, 1, maximum still 4. So cycle time still 4. Okay, always choose the maximum. Always choose the maximum. Flow time, you add all together. All right, this is the difference between. Okay. Yeah, so this is just a highlight of what is flow time. But I think the photo, this one photo show very clear message already. This one just another elaborate of what is cycle time. Oh, this one is more on the actual. This is actual. Actual we use C sub A. Just now the equation that we used previously, desired cycle time is C sub T. This one actual, you use A. This one is measurable one, the real thing that happened in the workstation. So this is just a side note. Okay. In real case, there will be a difference between desired and actual. This one you know lah. When you already did your ITP, if you already did your ITP in a factory, you know there will be something different between the design parameter and the actual parameter. Okay, this is just another side note just to explain the actual and design cycle time. So, which one we use? Okay, actual cycle time is the result from the balancing procedure. So later we will introduce you the balancing procedure to balance the flow. Okay, line balancing, just bear in mind, is also a try and error process. You try to reduce the efficiency, increase the efficiency, and minimize the workstation. So when you do line balancing, two more equations you need to calculate, which is the efficiency and workstation N, given by this equation and this equation. And the meaning of the symbol I put over here. Efficiency, basically you put efficiency. The general understanding of efficiency is output divided by input. Output divided by input. So what is this formula tell you? Ti is completion time for element. Is a sum of the time that you take to complete the element. All the element, because it's from I to J. So you combine from the first item until the last item. Or you can say that this is your flow time. Your flow time, the one that add all the time together. Divided by, this is your output, right? This is your input. So your input, you take CA, the actual time at each workstation, or actual time to process, multiply by number of product that you produce. Okay, sorry, this one is workstation, actual number of workstation, and multiply by actual cycle time. Then this one, minimum number of workstation, also we have one formula there, time divided by desired time. So this one is the total time in your process divided by the desired cycle time. So efficiency, as you can see from formula here, the biggest difference is one is the real number, or we call it actual number, actual performance, we go and calculate efficiency. If you only need to do planning for workstation, you use the design time, undesired time. Okay, quite standard, this formula. Let's work into one example. Let's give you some example or scenario to calculate this one. So let's say, there's one more terms before we go into there. It's called balance delay. Balance delay. Balance delay, the word delay itself means that when you have some production line, let's say the machine broke down. So what is the delay time for that? You talk about efficiency, right? Balance delay always linked with efficiency. 100% balance delay is actually a ratio. So you know that 100% is the full number. So when it comes about ratio, is 1. 100% is 1. And efficiency and balance expressed in percentage. Let's look at one example, right? So line balancing process. Later you will see what mean by this number. There's some procedure. I'll give you one example just now. Okay, first you draw diagram. Second, you calculate CD, this one. Because CD, you need to design the workstation, CD. First, you draw the precedent diagram. Second, you draw the desired cycle time. Then you calculate the N. Basically, you do line balancing. You are using this equation. Go and find the missing parameter, right? You find the CD first. Then, you draw the diagram so that you can calculate your CD and your CA. Then after that, you find the N and E. Okay, you group them together and you find the efficiency, right? We will follow these steps in the tutorial question. Yeah, so if the efficiency is not good or lower than what you expected, you can go back to the drawing board here to change some parameter and see if you're able to improve. Right. Let's look at one example. Okay, you can read from the slide here. So one company is producing a snack strip, fruit snack strips. This one maybe if you have kids, or you have a young brother, young children, then I think you have seen this one before, or maybe it's also one of your favorite as your snacks, right? So this is a fruit strips, right? So it's a snacks, right? It's a snack or candy, yeah, it's a candy. So you make it from the dry food, you add coloring, and in the process, you through some process to make this one, right? You mix the material, you roll and all this. So this statement also give you the precedent and requirement for each steps are given as below. So if you are having the handouts in the Teams, you should be able to see all the information before all these slides. So to meet the demand, the company needs to produce 6,000 strips, 6,000 strips every 40 hours per week. 40 hours per week. Design an assembly line with the fewest number of workstation. So this actually gives you the hints that you have two formula to use just now. You need to find the number of workstation to achieve the production quota without violating the requirement, the proceeding requirement. So you need to improve the layout. Okay, I pull all the information together. So you are seeing this precedence chart or precedence table. Okay, so in the handouts, you can see all this information. So this is called precedence. How to read the precedence? For example, you read from the left. You have 4 processes in the workstation there. First process, press the fruit. Second process, cut the strip. Third one, outline the fun shape, means you can have different shape of the output here. Put star shape, dragon, and so on. Okay. Then you roll out and do packaging. So it gives you some requirement at this column here. For example, before you cut the strip, you need process A. You cannot jump. Before you cut the strip, you need to press the fruit first. Then for process C, outline fun strip, you need to get the flat strip here. You need process A. You cannot jump. Then row packaging, you need to complete process B, process C. But before you come to the last one, you need to go through B and C. Then the time spent at each station. Process A use 1 minute. Process 2 use 0.2 minute. Process C use in 0.4 minute. Process D use 0.3 minute. Again, the unit that we use in our planning is in minute, not second. Second is in the engineering module that you calculate for Newton forces and all this. Let's work out this solution. First, develop the diagram, preceding diagram. So how to develop? Always pick the first station. Pick the first station A. Then A can go to what? A can go to B, right? After A, you go to B, right? So you draw B. After you pick the first station, you read the table. A will go to B, right? So you draw A and B. Read the preceding diagram. What does what's the B need? B need A first, right? So you draw an arrow. This is called precedence. B need A first. You draw an arrow, A to B. Because before you come to B, you need from A. Then you read C. You put the C on the diagram. Okay, well, this is just a side note. Okay, A precedes of C, so you can put anywhere in the space here. You put a C first. Then from the C, you read the table. C don't need B, but C need A. So C need A. So the product must come from A. Right? You draw the A to C. Okay, solve for a while. Try to process. Ask yourself, are you able to relate what is precedence mean? How do you relate this table into this diagram? I haven't do the last one. See if you're able to understand the logic behind this diagram. I start with the first station. Then I follow the next steps. I just draw anywhere in the space here. Then I read the precedence. So the precedence will always come from the precedence here. For example, B. B will see A. So you go to the A, draw arrow pointing to the station. Same with C. You put anywhere. C you can put anywhere. Okay, put any location. In this case, I just put below. You can put center also, no problem. Put center, put below, then you read from the table. C need A, so you draw from A to the station, to C. Then, are you able to complete the precedent diagram by looking at this table? Next one, D. D you can put anywhere. You can put anywhere. Anywhere you like. You can put even here. Okay? But usually I just put after the diagram here. You can put in the middle here also can, no problem. So next one, you put here. Again, a D you can put somewhere here, no problem. Okay? So put D here, read the table. You need B and C. So D need B and C. So D need B, so draw arrow from B You need C, draw arrow from C. Okay. This is a complete precedent diagram. Again, it doesn't matter if you pull your D to the center, as long as you're showing the correct arrow direction. It will become a triangular if you put your D in the center. No problem. This is just my way of presenting. You can put your D over here. Only you don't cross your arrow. Don't overlap your arrow, so that everyone know what you are trying to say. If you cross, then it's not a good precedent diagram. Okay. So again, you are flexible to play around the location. Important is the arrow direction. Okay. Important is the arrow direction. Okay. Okay. I think somebody tried to call me. Okay. Let's continue. Let's see. Okay, just now I think I lost you for a while, right? Correct? Just now I lost you for a while, right?
No, Doctor. Okay.
Okay,
No.
all right. Oh, because just now there's an error on my computer saying that the network is something. So you guys can follow from table to precedence. Anyone has question on how to produce this one? You understand, right? How to produce from this table, this statement or this table into preceding diagram? Any question? Any question?
No, Doctor.
Okay, good. So we're going to move forward using this diagram from now. Okay, once you have used this table into this diagram, you know you don't need this diagram anymore, but there's some information you need to put on the diagram first. So preceding diagram, workstation, arrow, and one more, the time. Remember to put the time beside the station. Okay, for example, A.1, you put just beside A, and so on. Okay, so put point 2, B, point 4, D, point. Okay, this is a complete precedence. So you need workstation, arrow, and time. You become the complete precedence. So normally this diagram will cost you 4 to 5 marks in the question. So make sure you know how to transfer information from the precedent table into diagram. Okay. So I pull to one side. Next, I need to group them together. But before I group, I need to do some calculation. So first one, I calculate the CD. CD give you the manager want to produce 6,000 every 40 hours in the week. So what I do, I convert 40 hour to minute. 40 hour I convert to minute divided by 6,000. My desired cycle time is 0.4 minute. Meaning I cannot, if my process slower than this time, I cannot achieve my target. So this is my desired, or you can say this is your target time. So your actual time maximum can go this one. It cannot go over than 0.4. If your process take more than this time, you cannot achieve 6,000 strips per day. 6,000 strips per week. Okay, so this one lock your answer limit already. This is a maximum number that you look for. So CD, you substitute the value inside there, you calculate CD. The next one, also you need to calculate number of station that I explained the formula just now. So how to find the top total time? You have 4 stations, right? You take this one, add this one, add this one, add this one. divided by desired cycle time. So 0.1 plus 0.2 plus 0.3 plus 0.4. Again, this one because the number is in sequence lah, so my answer is 0.234 like that. Okay, but in your answer you can write 0.1 plus 0.2 plus 0.4 plus 0.3, something like that. Okay, divided, use your calculator to find number of station. It come up to be 2.5. You need to round out the number of station. There's no 2.5 station, no. In the real case, you cannot chop the workstation into half one. Cannot. So you have to round out the station. If you get 2.1, it still become 3. Because this is the minimum station you need. If you get 2.1, you still need to increase to 3. Because you need 2.1 station, means you need more than 2 stations. You cannot reduce than 2, right? So there's some logic there. Even the decimal is small, like for example 2.1, you still need to round up to 3. If not your production line cannot run. The capacity cannot cope, because this is the minimum machine you need, 2.5. So round up to 3. Okay, next you have your N and D already. You need to make sure, you need to look at the diagram here. Maximum station that you can have is 3 workstation. And again, the game rules, or the rules that you can play with, is that you can combine. You can combine A, B, C, D become 1 workstation, or A can become a single workstation. You can combine A and B become 1. You can combine A and C become 1. You can combine any combination, it become workstation. All right. So this is the rules that you can play with. So you know that maximum is 3, maximum time is 4. So how do I build? I look at station 1. I start with 1. Okay, this is a table to help me to build my planning. First, I start with station 1. I assign station 1 to element A, meaning I lock the area in the factory. I put station A inside there. Remaining time is 0.3, because station 1 time need 0.1. So if I put A in the workstation there, I still have 0.3 minutes to play. Then you ask yourself, what is the remaining element that you can use? Or what are the remaining process that you need? Again, you need to be careful on the preceding rules, or directly read from the diagram. After A, what are the choices you have? After A, you only have B and C, right? From the diagram. After A, you still have 2 choices to go. You can either input B or input C to the workstation if you have remaining time. So between B and C, which one do you choose? If you choose B, does it fit into remaining time? Do you choose C? Do you fit into remaining time? In this case, I choose B, because if I choose I choose C, I will be run out of my remaining time. If I put process A and process C as my workstation, it will take more time than my desired time. So I cannot combine A and C. Now I can only combine A and B. Do you see the idea here? We want to design a workstation that meet the desired cycle time. In this case, I circle A and B, I combine the time, I get 0.3. I have 2 options. One is the green color, one is the red color. You find the total time if you combine. The top one you get 0.3, the bottom one you get 0.5. So the bottom one is not a good choice. You continue with the B. After you include B, your remaining time is 0.2, right? After you, I think, is it, sorry, you input A, you get 0.2. Okay, error here. If you input B, it should not be 0.2, it should be 0.1. Remaining time is 0.1 because you minus 0.2 here. Remaining times after you insert B is 1. There's a typo error here. Okay, so remaining is C and D. You look at C and D, it's more than 0.1, so stop there. You don't need to proceed anymore. Then you you lock station 1, A and B as workstation. Then you go for station 2. Station 2, you can choose C or D. You go for the C first because it's follow the process, A, B, and C. You cannot choose D. Why? Because D, you need B and C. You need B and C to process. If you put D here, you don't have C yet, so you start with C. So workstation 2, you choose C. Remaining time is how many? Your desired time is 4, you choose C. 4, remaining time is 0. Again, there's a typo error here. It should not be 2, it should be 1. 0.1 for B remaining time. So after C, remaining is D. So you cannot put any machine or any process here anymore because there's no more remaining time. Then you go for workstation number 3. So you cycle, you circle the station, become one station. Then you go for station 3, D, remaining D. So you put D as a workstation. The design time is 0.4, the remaining time is 0.1. Then there will be no more remaining element. You stop the process. And then you highlight, not highlight, but you cycle just to identify the workstation. So this is the workstation that you can work on. You have 3 workstations that can meet the desired cycle time. So how do you draw assembly diagram? Square means workstation. Square means workstation. Put workstation 1, 0.3 minutes. You continue C, 1 box here. Draw the arrow. Put workstation number 2, 0.4. Then go to the last station, workstation D. You get 0.3. From this diagram, you know what is the maximum cycle time, right? So efficiency, you use this formula. E equal to all the time taken to produce at 0.1, 0.2, 0.4, 0.3 on the top. Total time needed. Below N is the number of station, number of workstation. You only have 3 workstation, right? 3 box or 3 cycle. 3 circle there. Means you put a 3 there. CA actual time, you check 0.3, 0.4, 0.3. Pick the maximum. Maximum is 0.4. Put 0.4 here. The efficiency is 83%. You get this one is a ratio. You get 0.333, 0.833. You convert to percentage. Convert to percentage, 83%. Right? So maximum value is 1. But in this case, you get 0.3, which is 83.3%. This is how you calculate. Okay, we stop here. Let me end the recording.